Okay, so imagine you're listening to a symphony, right? And as you hear the music, you literally see an explosion of color. What if I told you that's not some kind of metaphor? It's a real neurological trait where the senses literally blend into one.
And no, this isn't something out of a sci-fi movie. For a surprising number of people, this is just their everyday reality. It's a genuine way of perceiving the world, and it's called synesthesia.
Which, brings up a really fascinating question. How can you be sure that the way you see the world, the way you hear and feel things, is the same as everyone else? It kind of throws our whole idea of what normal perception even means right out the window.
So what's actually going on inside the brain to make these incredible experiences happen? Let's get into the nitty-gritty of the neurology behind it.
Now, it's super important to get this. This is not someone's imagination running wild. These sensory experiences are completely involuntary and incredibly consistent. So if the number 7 is a bright sunny yellow for you as a kid, guess what? It's going to be that same yellow when you're 80. It's a genuine neurological trait, not an illness. What's really interesting, though, is that not everyone with synesthesia experiences it in the same way. We can basically break it down into two main groups. You've got your projectors. These are the people who literally see the colors out there in the world as if the letter A was physically printed in red ink. But then you have associators. For them, it's more of an internal thing. They don't see the red A on the page, but in their mind's eye, they have this powerful, undeniable knowing that A is red.
And believe me, the variety of these experiences is just incredible. The one you hear about most is grapheme chlor, where letters and numbers have their own specific colors. Then there's chromesthesia, where sounds trigger colors. But this is where it gets really wild. People with lexicogustatory synesthesia might literally taste bacon every time they hear the word jail. I'm not making that up. Or how about mirror touch? That's where if you see someone get tapped on the arm, you actually feel that same sensation on your own arm. Insane, right?
So what's it actually like to live in a world like this? Let's talk about the lived experience, because for a lot of people, this is a huge creative catalyst. Take the famous writer Vladimir Nabokov. For him, the alphabet wasn't just a bunch of boring symbols. It was a rich, textured palette. I mean, listen to that. A fold of pink flannel. You can almost feel how his writing was just bursting with this extra layer of sensory detail, all thanks to his synesthesia.
And it's not just writers. The jazz legend Duke Ellington had it too. But for him, it was all about sound and texture. It's amazing. He said a note D might be dark blue burlap if one musician played it, but a G from another player could become light blue satin. He was literally using this sensory feedback to compose. 2, to paint with sound using his orchestra. This is still happening today, of course. For an artist like Pharrell Williams, synesthesia is basically a tool in his toolkit. He talks about how his massive hit Happy is a mix of yellow and red. For him, it's not just some cool abstract idea, it's a practical guide in the studio. He knows the song is right when the colors match up. Now, it's easy to think of this as some kind of creative superpower, and in many ways it is. That extrasensory layer can be an incredible memory tool. But it's a double-edged sword. Imagine a crowded, noisy room. For some synesthetes, that's not just loud, it's a chaotic, overwhelming blast of unwanted colors and shapes. And for someone with that mirror touch synesthesia we mentioned, watching a medical show can trigger real physical pain. So it's not always a picnic. So what exactly is the science here? What does the latest research tell us about the architecture of the synesthetic brain? Well, it turns out it's way more complex than just a few crossed wires.
Right now, scientists have two main working theories. The first one is called cross-activation. The best way to think about it is like this. A baby's brain is full of messy, overlapping telephone lines. As we get older, our brain prunes them, cleaning everything up. This theory suggests that in synesthetes, some of those crossed lines just never got pruned. The second idea, disinhibited feedback, says we all have those crossed lines, but most of us have a sort of gatekeeper that stops signals from spilling over. In synesthetes, that gatekeeper is just a little more relaxed.
And here's a really cool recent discovery. A 2024 study found a huge biological clue. People with synesthesia have much higher levels of a protein called BDNF. Now, why should you care? Well, BDNF is basically like fertilizer for your brain. It helps it grow and form new connections. This is a big deal because it suggests the synesthetic brain isn't just a leftover from childhood. It might actually be more complex and specialized.
And we're not just talking about a minor tweak here. Cutting-edge research is showing that the synesthetic brain seems to have a totally different operating system. It's not just a typical brain with a few extra wires plugged in. We're talking about a fundamentally different architecture from the ground up. It's gotten so advanced that researchers can now predict who might have synesthesia just by looking at specific biomarkers. For instance, they found differences in intracortical myelin. That's basically the insulation around the brain's wiring. They've also found that the synesthetic brain is a more distributed network. Think of it this way. A typical brain might rely on a few major airport hubs to move information around. The synesthetic brain, it's like it has way more regional airports, making the whole system much more interconnected. So, where does all this lead? What does this mean for the future, not just of our senses, but for our technology? The implications here are pretty mind-bending. Get this. We're actually trying to reverse engineer synesthesia to build better tech. By learning how the brain naturally blends information from different senses, we can design things like AI and virtual reality that feel way more intuitive, seamless, and, well, human.
And this has already led to some incredible tools called sensory substitution devices. This is where it sounds like pure sci-fi, but it's real. There's a project that uses a vest with haptic feedback to translate visual information into vibrations, essentially letting someone who's blind feel the world around them. There's another device that lets users taste shapes by translating them into tiny electrical patterns on their tongue. We are literally teaching the brain to use one sense to do the job of another.
All of this leaves us with a really profound final thought. What synesthesia proves, beyond a shadow of a doubt, is that our perception of the world isn't a perfect photograph of reality. It's an active, dynamic construction project happening inside our skulls. And if some brains are wired to taste words and see sounds, it just makes you wonder, doesn't it? What are the real limits of human perception? And what else might we be capable of experiencing?